Cellular renewal. The invisible blueprint of aging cells are the basic structural, functional, and biological units of all living organisms. Often referred to as the building blocks of life, the human body is made up of roughly 30 trillion of them. Cells provide structure for the body, take in nutrients from food, convert those nutrients into energy, and carry out specialized functions, holding the entire master code for your survival. If you look in the mirror, you see a single, static human being. But beneath the surface of your skin lies a thriving, microscopic metropolis. You are not a single entity. You are a cooperative alliance of 30 trillion individual living cells. Every heartbeat, every thought, and every breath you take is dictated by the health of this microscopic workforce. If you want to understand how to slow down time, you have to stop looking at the body as a whole and start looking at the health of the cell. Imagine your body is an ancient, grand castle. To keep the castle from collapsing, individual bricks must constantly be replaced as they weather and crack. This is the exact reality of your biology. Your cells are constantly dividing, dying, and replacing themselves. In fact, right now, as you listen to this, millions of your cells are dying and millions more are being born. Your entire skin replaces itself every few weeks. Your liver replaces itself every year. In a very literal biological sense, you are not the same person you were a few years ago. But if our cells are constantly regenerating, why do we age? Why don't we just stay young forever? The answer lies in the fidelity of the copy. Over time, due to environmental stress, poor nutrition, and toxic buildup, errors slip into the copy. Think of it like taking a pristine document and running it through a photocopy machine, then taking that copy and copying it again, over and over. Eventually, the text becomes blurry, pages get distorted, and the instructions become unreadable. This accumulation of genetic typos is the root cause of aging. Crucially, this copying process is governed by telomeres, which act as the protective plastic caps at the ends of our chromosomes. Every single time a cell replicates, these telomeres get slightly shorter. Think of them like a burning biological fuse. When the fuse runs out entirely, the cell hits the Hayflick limit, the maximum number of times a human cell can safely divide. At this critical junction, the cell can no longer replicate, pushing our tissues into a state of structural decline. When a cell becomes too damaged to function, one of two things happens. Ideally, it undergoes apoptosis, a programmed cellular suicide where the cell neatly dismantles itself for the good of the organism. But as we age, some damaged cells refuse to die. Instead, they turn into what scientists call senescent cells, or zombie cells. These zombie cells stop dividing, but they refuse to clear out. Instead, they sit inside your tissues, secreting toxic, inflammatory chemicals that infect and damage the healthy, young cells around them. This creates a cascade of chronic inflammation that degrades the extracellular matrix, the scaffolding that keeps our tissues firm and youthful. The frontier of longevity science in 2026 is entirely focused on this cellular battlefield. We now know we can support this system through autophagy, the body's internal recycling program where cells actively clean out their own damaged parts and debris. By promoting cellular cleanup and clearing out these toxic zombie cells, we allow our healthy cells to replicate with pristine accuracy. Aging is not an inevitability written in stone. It is a breakdown in cellular communication and repair. You are only as young, as energetic, and as resilient as your cells. By mastering the environment you put your cells in, you change the blueprint of your future. Take care of the cells, and the body will take care of itself. This is the foundation of life.